Hello, we are Group 3 in ALA 270. We have spent the past semester researching approaches to providing clean and safe water to the village of Sidi Khalifa in Tunisia. Due to the hot, semi-arid climate, topographical conditions, and improper management of water resources, water scarcity remains a pressing issue for people across the country. Water scarcity has historically been a detriment to Tunisians' health, hygiene, and socioeconomic development. The shortage of water has led to groundwater overexploitation, which is the most widespread means of accessing clean water in the country today. In intensive farming regions, groundwater is being extracted at a faster rate than the underground supply is renewed, and it is coming from non-renewable groundwater sources. This means of extracting water from underground is limited and negatively affects the climate. The current water management system is unsustainable, and we have a better, more cost-effective solution.
Sand dams are a low-cost, low-maintenance, sustainable, and permanent solution to water storage issues. They take approximately 2 months to build, and they provide a filtration system through the sand particles that results in safer, more potable water. Sand dams provide a solution to both everyday people and farmers. 80% of water resources of the total water potential in the country is used for agricultural endeavors. Why a sand dam, you may ask? It provides year-round safe water, a sustainable, permanent solution to water storage issues. It costs much less than water treatment and is actually 3 to 100 times lower cost than other technologies, and also a filtration system through the sand particles that results in safer, more potable water. And additionally, mosquitoes are unable to breed in this situation, which reduces the possibilities of malaria and other diseases that might be in the water.
In order to determine a specific village in Tunisia for this project, we needed to consider the 4 preconditions for a suitable sand dam site. Firstly, a sand dam must be sited on a seasonal river with clearly defined riverbanks. Secondly, the riverbed must be sufficiently impermeable as to retain water. Thirdly, the river must have sufficient sandy sediment. And fourth, a sand dam must be sited where the bedrock or a suitable impermeable layer is accessible, usually no more than 3 meters below the existing riverbed surface. Sidi Khalifa is the village that we chose for the location of our sand dam because it is able to satisfy each of the 4 preconditions for a suitable sand dam site. In order to find a village that had bedrock, we utilized a geology map to look at the topography of Tunisia. It is also located in a region that is closer to the Mediterranean Sea than it is to the desert, which is essential for the seasonal streams that are necessary for sand dams. In other words, Sidi Khalifa experiences a rainy season, which we need for sand dams.
When it rains, the dam captures the soil-loaded water behind it. The sand in the water sinks to the bottom while the silt remains suspended in the water. As the river flows, it brings more sand along with it, which collects upstream of the dam. This in turn creates more water storage capacity. Behind the dam, the water is safely stored in the sand where it is protected from evaporation. As you can see in our prototype, 1 to 3% of the water flowing downstream is retained by the dam. When the dam fills with sand, 25 to 40% of the volume behind the dam is water. Once the dam fills with water, users can extract the naturally filtered water throughout the year until the next rainy season. There are many benefits to sand dams and their ability to produce safe drinking water. Sand dams are low cost and low maintenance and can also be community owned and managed. They combat desertification by recharging groundwater and creating opportunities for sustainable land management. Sand dams mitigate climate change by creating water security and the time to practice climate-smart agriculture. They reduce conflict by increasing access to water for people and livestock in water-scarce dryland environments. They support disaster resilience by creating a buffer against drought and enabling vulnerable people to improve food production.
So, moving on, we're going to talk about the whole process of extracting water from a sand dam. Now, a sand dam is a wall built across a seasonal sandy river. And since we're making the use of a stone masonry dam, the dams are built by securing a stone masonry wall across river beds and by placing a pipe under this barrier. So when it rains, the water carries sand downstream and it deposits it against the concrete wall. Now, eventually, the area behind the wall becomes filled with the sand. Now, during the rainy season, sand dams provide a basin of water that can be used by villagers and farmers alike. At the end of the rainy season, water remains trapped in this piled up sand, and the water gradually drains into the pipe and can be collected using various methods. The most common way to abstract water from a sand dam is by means of a hand dug scoop hole in the riverbed. Now, this is a traditional method and one that has been used from time to time. The hole is scooped out at first, and the water that refills the scoop hole is abstracted. Now, this method is susceptible to pollution, especially by animals. However, this can be avoided by barricading all around the scoop hole with the use of thorny bushes. The water from the scoop holes is relatively clean, however, it is recommended that it should be boiled or treated before drinking. Now, a well is the better alternative for a scoop hole. It tends to protect the water quality given the well has adequate protection since animals in river water cannot enter. Now, a maximum of 3 wells should be located on the upstream side and close to the dam embankment, approximately, within 3 to 10 meters. This is because the sand reservoir will be deepest just upstream of the dam. Water can be extracted from a well using a motor pump or a hand pump. A hand pump in this case would be recommended just over the motor pump given the technological and maintenance constraints. Now, lastly, an outlet can also be installed as a pipe at the bottom of the dam just above the impermeable layer. Now, the pipe should be covered fully with filter material and geomembrane to prevent entry of sand and silt. The disadvantage here would be that it can weaken the dam structure, and maintenance is also complicated. This can also be a more expensive option than the ones aforementioned. So below here, you see a table that includes the estimated costs of materials that it takes to build a sand dam. Now, these numbers are borrowed from an existing project where a sand dam was built in Kenya a few years ago. As you can see, cement tends to be the most expensive item, and it usually is around 60 to 70% of the total cost of materials. Now, the cost of materials for a sand dam also differs based on the size of the dam being built. For instance, a small sand dam would comprise of about 190 bags of cement, and here each bag consists of 50 kilograms of cement. On the other hand, an extra large sand dam would use about 1,000 bags of cement. So for our location, City Khalifa, we concluded that a large sand dam, which consists of 550 bags of cement, would be the most appropriate. Now, once the materials have been accounted for, there are still quite a few major costs to consider. As mentioned before, there are a few ways of extracting water from the sand dam. So naturally, building the suitable technology or method has its own costs. Now, for instance, an infiltration gallery and pipe through the dam would cost about $300 to build. However, the most preferred and sustainable extraction method would be the infiltration gallery and shadow well with a hand or motor pump, but this can come out to be almost $1,500. Another significant cost with sand dams is the labor cost. Now, this can be divided up into skilled and unskilled labor. Based on past sand dams being built in Kenya and Ethiopia, we found that skilled labor and unskilled labor can come out to be 13% and 40% of the entire cost, respectively. So, keeping that in mind for this project, the cost would be about $945 and $2,900 for skilled and unskilled labor, respectively. Now, one thing to note, however, would be that this cost can actually be scaled down based on community participation. So, if the town of City Khalifa can come up with a system or devote some in-house workers, it would certainly bring down the overall cost of building the dam. However, as it stands, the total estimated cost of building the sand dam would range from $11,500 to $13,000. And with that, we'd like to thank everyone for their time and for listening in, and we open up the floor to any questions.